Hello, everyone. Today we're going to be going over Descartes' rule of signs and also answering a couple of questions related to this rule as well. Okay, so what is Descartes' rule of signs? It says basically to let an f of x be a polynomial function that has real coefficients. The number of positive real zeros of f is equal to the number of changes in sign of the coefficients of f of x, or is less than this by some even number. Also, the number of negative real zeros of f is equal to the number of changes in sign of the coefficients of f of negative x, or is less than this by an even number. So the very first thing I'm going to do to answer a question like this, where it says to determine the possible number of positive real zeros, negative real zeros, and imaginary zeros for these, is I'm first going to find f of negative x. So let's do that. Let's find f of negative x. So f of negative x in this case is going to be negative x to the power 5 minus 6x to the 4 minus 11x cubed minus 10x squared minus 5x minus 1. And now I'm going to count out how many positive real zeros, negative real zeros, and imaginary zeros there must be. So for positive real zeros, let's just remind ourselves what's the criteria. The criteria is looking at the original function f, how many changes in sign is there? Okay, well, it starts off positive, and then right here we have one sign switch, right? We switch from positive to negative, so that's 1. Then we switch to positive, so that's 2 sign changes. Then we switch to negative again, so that's 3. Then we switch to positive again, that's 4. And then we switch to negative again, so that's 5. So in this case, the answer is there are 5. And so what does that tell us? That tells us that there's either 5 positive real zeros or there's less than 5 by an even number. So there could also be 3 possibly or 1 possibly. So those are the possible numbers of positive real zeros. So I'm going to write that down. Positive real zeros. Okay, then for negative real zeros, we're going to do the same exact thing. We're going to look at f of negative x and determine how many sign changes there are here. Well, it looks like we start with a negative, and then still negative, still negative, still negative, still negative, still negative. So that tells us what? That tells us that there are 0 sign changes, so therefore there are 0 negative real zeros. And so there we go. All right. And so the other thing that that Descartes' rule doesn't really explicitly state, but that we can figure out based on other things we've done in the course so far, is what about imaginary zeros? How many imaginary zeros are possible? Well, here's the thing. We know that overall, between positive real zeros, negative real zeros, and imaginary zeros, there must be 5, or there might be some repeats in there, and that's fine too. But if we say that repeats count for double or triple or etc., then there must be 5. So therefore, the possibilities are there could be 5 real zeros, or sorry, I should say positive reals, positive real. And if there is 5 positive real zeros, that means there would be 0 imaginary, right? And also, of course, 0 negative real zeros. And actually, I'm just going to put PR for positive real. Then there's 0 negative real. And then there would also, in this scenario, because we know that there's 5 zeros in all of these, that means there would also be 0 imaginary zeros. Possibility 2 is there could be 3 positive real, and then again 0 negative real, and 2 imaginary. That's possible. Or there could be 1 positive real, 0 negative real, and 4 imaginary, right? Because keep in mind that all 3 of these numbers every single time have to add up to 5, right? Because that goes along with our fundamental theorem of algebra. The corollary in there specifically that states that the degree must be the same as the number of zeros when we include repeats repeats as multiples, and also including imaginary roots as well as roots in that context as well. All right, so those are the possibilities. Let's do one more example like this with b. So first thing I'm going to do here again is I'm going to find f of negative x. So f of negative x is going to give us negative x to the 7 minus 2x to the 6 plus 4x to the 4 plus x cubed minus 8x minus 9, like that. And now I need to count and figure out how many sign changes there are here. All right, so let's do that. So for the first one, looks like there's one sign change right here because we have a positive leading coefficient, and then we switch to negative, and then we switch again to plus, switch again to minus, switch again, and switch again. So it looks like we switched 5 times. So that means there must be either 5 positive reals or less than 5 by an even number. So either 5 or 3 or 1 positive real. So those are our possibilities for positive reals. Okay, what about negative reals? Well, let's see. We start with a negative here, and then we still have a negative, so that's not a sign change. But then here, when we switch to positive, that's sign change 1. Then we stay positive for x cubed, so we can skip that one. And then we switch again back to negative again. So we switch twice, and then we stay negative for the last one. So in this case, there are 2. So therefore, there must be either 2 negative reals or less than 2 by an even factor. So either 2 or 0 negative reals. Okay, and overall, there must be 7. Overall, any scenario must add up to 7 because this is a degree 7 polynomial, right? Because that leading term is to the power of 7. Okay, so therefore, what are the possibilities here? The possibilities are that we could have 5 positive real and 2 negative real, in which case we've already added up to 7. So here we would have 0 imaginary. Or we could have 5 positive real and 0 negative real, which would mean that there are 2 imaginary in that case, since all of them have to add to 7. Okay, so that's it for 5 positive real. There also could be 3 positive real and 2 negative real, and in that case, there must be 2 imaginary in order for this to add to 7. There also could be 3 positive real with 0 negative real, which would mean there'd have to be 4 imaginary in order for all this to add up properly, to add up to 7. And then what else? So we've accounted for the possibilities with 5 positive reals and 3 positive reals. What if there's 1 positive real? If there's 1 positive real and 2 negative reals, then that means that's 3 roots right there. We'd have to have 4 more. So 4 imaginary in that scenario. And then our last scenario is 1 positive real and 0 negative reals, meaning that there would be 6 imaginary. Actually, let's pull this up a little bit so you guys can see that. 6 imaginary, because again, we need to add to 7. If we have 1 positive real and 0 negative reals, that means there's 6 left, and those 6 must be imaginary. And so there we go. But yeah, I hope this was helpful for everyone. Feel free to leave any questions you might have about this in the comments, and we hope to see you for the next one.